Okay, hey everybody, my name is Nicole Turechki and I'm a knowledge engineer here at Ontotext, and I'm going to do a demo of Ontotext Refine, which is our tool for RDFization of tabular, JSON, and XML data for a potential use as part of a verification workflow tool in the IDAO project. So I'm going to share my screen. Okay, a quick word on Ontotext Refine. It's a tool that we have built on top of OpenRefine, which is an open source tool for data wrangling and data transformation. And Ontotext Refine adds some very useful capabilities, which I'm going to show now, which are RDF production and a command line interface, which allows that to be part of a pipeline. The tool is available at the Ontotext website. The documentation is accessible also, and the tool is downloadable. It's not an open source tool, but it's a free to download and use tool without any restrictions. So my demo today will be to produce RDF out of the drugs and FDA data files, which is a database of the drug applications shared by the FDA. So here is the data model. I'm not going to go through it. I'm only going to RDFize the product table, which has enough little quirks that need to be addressed, that it is more than enough for the demo. So first, I have already downloaded my data, and I'm going to load it into the Ontotext Refine tool. Okay, so here is my products table. So this, for those of you who know OpenRefine, for now is just the OpenRefine interface, which is table manipulation, data cleaning, and data wrangling. I have a model which is in the form of a turtle file example, which I'm going to show here. And actually, I'm going to go through the model and look at the different steps that I have to do on the data in order to prepare it for RDFization. So my workflow will be first to work on the table, prepare it for RDFization, and then I'm going to show you how we do the mapping. And at the end, I'm going to use both of these to create a pipeline which automatically downloads the data from the FDA websites and produces RDF, which corresponds to my model. Okay, so my model has the following entities: an application entity, which uses this identifier here, the application number ID. Let me zoom in a little bit so that we can better see. Just let me create my project first. Okay, now it's creating the project. It's quite a big project. It has I think 17,000 lines or something like this. Okay, let's see. So my objects I'm going to be creating an application object with this identifier here. So I'm going to create this ARI here. Then for each application, there is a one-to-many relationship with product. So just let me filter out this particular application. I'm going to show you what's going on here. Okay, text filter. As you can see, I can use the tool for data exploration. It's very useful for this. So let's superimpose the model this way. And so here, this is actually the data that I use to create the model, which I will illustrate the different quirks. So first, I have to figure out how I'm going to create my identifiers. You can see that for the product and application identifiers, I have IDs in the table. So each application, an application can have more than one product. But then for the active ingredients, there is quite a difficult issue to untangle. So you can see the active ingredients are actually multi-valued fields in the active ingredient column and separated by a semicolon. And also they're parallel arrays. So the strength here, this 1.5 mg corresponds to this thing here, and the 5 mg corresponds to this thing here. So I have to align those using the tool in order to represent them correctly. So here is how it's going to look in the end model. So I have one node, which I'm going to use the active ingredient name to create the RI. And then these nodes are actually going to hold the information, what was the concentration of the active ingredient in the application in question, in the product, in the application cache. So it's a double many-to-many relationship in the data. Okay, and also there is this difficulty here. So you can see that I have one column called form, which has tablet oral, and actually it encodes two bits of information. What is the form of the drug, and what is the route? So I'm going to split this and encode them this way here with a form relation and a route relation. And also I have this information here, the reference drug, which are Boolean values, which I have to represent in the right way, which is using Boolean values in the RDF. Okay, so let me show you how I'm going to do this. So first step is to work on the table. So the table, I'm going to first split this thing here into, I'm going to split this into two columns. So I'm going to split it horizontally. So edit columns, split into several columns with the semicolon as a separator. Next, a little bit more difficult is to handle the multi-valued fields in the strength and active ingredient column, and there actually what I have to do, I'm going to split them differently. I'm going to split them vertically, so I'm going to create new rows, one row per value. So split multi-valued cells by the semicolon. I'm going to show afterwards that it split multi-valued cells again by the semicolon. And so just let me show what this did. So this for this Haikudan product. So let's search Haikudan here. As you can see, I have one value now with the strength. And actually what happened is that underneath it created a new row, but it didn't repeat this information here. So in order to repeat it, I'll use an operation called fill down, which will basically fill down the empty rows with the value from the row immediately before. So this is here. I'm going to transform fill down product number, because I also needed transform fill down. And so let's go back to our example here. And now you can see I have my values nicely aligned. There's some more housekeeping, such as trimming. So I trimmed this because there are these leading white spaces that need to be fixed. So I want to trim this one also. Okay. And so while exploring the data, I also saw that there were some strange values, which is more often than not this happens. There were some strange values, which are stuff that looks like this. So I have a strength value, and then I have some text here that its place is not there. So this is the semantics of this. It means that the product was not discontinued when this product was not discontinued. So this text shouldn't be here. It should actually correspond to a Boolean value. So I'm going to show you how I'm going to create this. I'm going to create a new column. Based on first, I'm going to create a filter where I'm going to filter out only these cells. So it was continued. This, but application number, it was here in the strength. Continued. So I have 400 cells, and I'm going to create a new column, which I'm going to call this continue. And then I'm going to add a value, static value, which will be true. So this will be only where I have this text here. And then the next part is just to remove the text because I don't want it in my values here. I only want the clean values. So here I'm going to do a transform, and I'm going to replace text here with nothing. It worked. Yes, it worked. We can even check if it worked. I'm going to do a facet on the discontinued, and let's see what happens where it is true. And I don't have my text here, which is good. Okay, so now my table looks goodish, and I'm going to produce. Now I'm going to do the RDF mapping. But first, I want to draw your attention to the undo redo tab here, which actually hosts a full history of the operations that I just did, which means that I can do an undo redo, so I can get my project in its initial stage, and I can apply each of the steps in sequence. And I also, which I'm going to use later, I have a JSON file with all these operations listed in a JSON file, and I'm going to use that afterwards to automate the steps. Okay, so now that my table looks good, I'm going to produce an RDF mapping, which is this is the part that we have added on top of OntoRefine, and it's very simple. It is a visual mapping interface. I have the columns here, and I basically can drag and drop them into different positions, subject, predicate, object position, and gradually, iteratively build my RDF while looking at examples. So first, let's go back to the model. So first, let's build the application node. So I'm going to first to say that the application. So first, I'll need a prefix actually, which is this prefix here. I'm going to add it here. Okay, I have my prefix. I'm going to change my base URL also so that it looks a little bit better. And I need, what do I need? I need a node in this form here. So I'm going to create it using a GREL. GREL is an expression language which allows me to do stuff like concatenations. And I'm going to concatenate the application and the content of the application number column. And here is my subject. This is a application. Right? Okay, I have my first triple. Have a preview, and it looks good. See application with the identifier, and it looks good. Okay, I can go back into configuration mode. Now I have to, so application key have product, so I can add directly triples here, product, and the product I have to reuse a GREL expression because here I'm going to create a product IRI, which will be for product. And remember, the product is a concatenation between the application number and then the product number. Okay, product number. And does it look, question is, does it look good? No, it doesn't. Why doesn't it look good? Product number file. And of course, it needs this thing here. Oh, now it looks good. Okay, and the data type is an array. So, okay, I have my product. Again, preview mode. Yes, this looks exactly as I wanted to look in my model. I don't have much time, so I'm not going to do the entire mapping now. I'm going to open a project where I have already done it and just walk you through it. So just let me just save this, and I open a project where it's already done. Here it is. And here is my RDF mapping, which has all the triples that come from the data. So here, for example, let's go into preview mode. And here is my application, product, the form, the form and the route are separated. I have is it a reference drug, a boolean value, the drug name, a string, the active ingredient, and here you can see how I have created an IRI. Let me zoom in a little bit. I've created an IRI with the application number, product number, and then the string value in the IRI, which the space has been replaced by an underscore. I can show you how this is actually done. It's done with the grep expression. So here I have the different columns. So the application number column, product number column, and the active ingredient column, which I have called the replace function directly here, which replaces the space character with an underscore character, something that we often have to do. The strength and so on and so on. So my mapping, I'm happy with my mapping. And now I can open it into the GraphDB instance. And so now what happened is that the OntoRefine created a virtual Sparkle endpoint, and I opened it using the GraphDB instance, and my mapping is directly generated in the form of a Sparkle query. So this, I know it's a mouthful, but let's go through it. I have a construct part, which constructs my graph, which expresses the graph pattern, and I have a where clause, which contains a service clause, which is the remote Sparkle endpoint, and then I have basically a set of expressions. Here is my grep expression, and it references the different columns in form of variables, and I can do stuff in Sparkle with the variables. So this is exactly the same mapping that I constructed using the visual interface now as a Sparkle query. Let me add a limit not to overload the endpoint. And we're good. And here is how my RDF looks in the GraphDB endpoint. I'm happy with how it looks. I can even see it visually. See, pretty nice. Have my different, so here is the application. This is an application. This is a product, injectable, injection, that, oops. The drug name and so on. So it looks pretty good. And if I want to insert it into the database, I can just change this to an insert query and run the thing. I'm not going to do it now. But what is more important is that once I'm happy with this, with how the mapping process has been defined, I can actually extract the definitions, which is the operations from OntoRefine and the mapping in the form of a Sparkle query, and use them as part of a pipeline. So I'm going to show you how to do this now. So I'm going to go back to the OntoRefine, to go to this undo redo tab, extract, and I'm going to save this JSON file as something called ops.json in the pipeline folder as this JSON here. So I'm going to save it. Let me show you how it looks. This is how it looks. It's a JSON with all the operations. So let's see what have I done. I've trimmed some stuff. This is the field down cells. This is what I showed you in the beginning, and so on. So these are the operations that will be applied to any new data set. Then I can do the same with the Sparkle query. So this Sparkle query here, I can copy it and paste it in a file, save it as a file. So let's look at the file. It's called mapping.rq. And here it is actually a Sparkle. Well, so here is my Sparkle mapping as a construct query. And these are the only two things that I need in order to run my operation on new data. So here is how the call looks. Just let me wrap. So here is the OntoRefine command line interface command. I tell to transform. The input data is in CSV format, and then apply the operations JSON, mapping RQ file. Here is the refine instance. URL and produce this products TTL file. Here, because I can do this, I can actually use other tools to basically get the latest data from the website, unzip it, and apply the transformations that I have already defined. And I'm going to show you how this looks. Mhm. If I can zoom in a little bit, I can't. Sorry about that. But okay. Okay, so now it downloaded the files. It unzipped them into the temporary directory, which is here. It unzipped them here, and now it's running it's applying the transformations and then applying the mapping to produce the RDF. It's done, and hopefully in the RDF folder I have a products TTL file which has very nice RDF. So look, for example, this application here has how many products? 13 products, and each of these products has a definition. So it's probably different. I guess it's different concentrations of the stuff, but because you can see form and route are separated. These are proper Boolean values. There are separate objects for each ingredient with its concentration and so on. So I'm happy with the RDF, and I can schedule and run my call on every new update on the drugs website, which is probably, I think it's weekly updates or something like that. So this was it. I showed you how we can quickly wrangle some data, analyze some data, wrangle it, create a mapping, apply the mapping, and then apply this as part of a artificialization pipeline. Thank you for your attention, and bye.